All right, I'm back. So here is the second half of 3.3 notes, and we are on to page 10 in the notes packet. All right, so we're going to talk now about these things called, these are kind of cool, difference quotients. Now, what's a difference quotient? Well, we know a quotient has to do with division, and a difference has to do with subtraction, right? So we have difference quotients where we're dealing with subtraction and division. So notice for all of these, there's certain formats, right? F of x minus f of a over x minus a. Oh, that looks really familiar. Doesn't that look like f of b minus f of a over b minus a? Except instead of the b's, we just switched them to x's. Same exact thing. So this was your average rate of change or your slope formula. Same idea, though, now with different functions. It's called a difference quotient because we're taking a difference, and then a quotient in between them. But it's just another way to express that slope. In example 5, we have a different format, okay? But it's still a difference, f of x plus h minus f of x over h. So we still have a difference and we still have a quotient. And so it's a different format. We're going to practice with these different quotients for a couple days here. So tomorrow we'll do more practice with this. But you'll get good at them for sure. They're kind of neat just because they always simplify pretty nicely at the end. So let's go through and see what they want us to do. They give you a function, and then they ask you to find a difference quotient according to this function. So f of x equals x squared is our function. They want us to find f of x minus f of 5 over x minus 5. Easy, right? So what's f of x? Oh, well, it's just x squared. So I'm going to replace that with x squared. What's f of 5? Oh, I just take a 5 and plug it in here, right? It would be 5 squared, otherwise known as 25. Agreed? So this is just 25 over x minus 5. Now these are all going to still have x's in them, so you're going to have to simplify them and have an x in your final answer. Well, this is a nice one to simplify. We can do d2s, difference of two squares, factor that numerator, and then we love it. Those cancel, and my final answer is just x plus 5. Let's try the second one. This one's a little more complicated, okay? G of x equals x squared plus 3x. So our g function here is a little more complicated than that one was, but we're going to do the same way. We're going to take g of x minus g of a. Now they're not even using a number. Here they used a 5. Here there's no numbers. It's all going to be x's and a's, and we're just going to simplify. So what's g of x? Well, g of x is this whole thing. So it's x squared plus 3x minus g of a. Well, g of a is the same thing, except I just plug in a's instead of x's. Just be really careful when you're subtracting that you, that you plug in a's and that you subtract the whole thing. So that negative here in the middle is going to distribute to both of them. Okay, this is all over x minus a. So I'm going to have x cubed plus 3x, x squared, plus 3x minus a squared, distribute that negative, minus 3a all over x minus a. Now we got to try and factor this. If I try and group it the way it is, it's not going to help. I'm going to have x's here and a's here, and that won't help us. So what if we rearranged it and put the x squared and the a squared together, and then put the ones with the 3's together? Let's try that. This is still all over x minus a. So when I factor this, this is a difference of two squares. I get x plus a, x minus a. Ooh, that's nice. Can take out a GCF here of 3, left with x minus a. And then this is where I look for that overall greatest common factor that comes out in front. And then what's left over? X plus a plus 3. All gets grouped together in one big parenthesis, all over x minus a. This is why these are so much fun, because at the end that denominator should always cancel out, and I'll have x plus a plus 3. Done. Kind of neat? All right, so let's try these other ones now. These are difference quotients with a different format. These are the ones with h in them. You're going to get used to seeing these as well. So let's try f of x plus h minus f of x all over h. Okay, so f of x plus h, this is where I take that whole x plus h and plug it in for x. Make sure you're putting it in with a parenthesis. So I'll have x plus h squared plus 1. That whole thing is f of x plus h. Minus just f of x, well, that's this whole thing, parentheses x squared plus 1, all over h. You want to make sure this distributes. I'll have x plus h squared plus 1 minus x squared minus 1. Oh, well, that's nice, because what happens to those 1s? They're gone. And now you have two choices of how you want to solve this. So hopefully you're seeing both ways. One way would be to notice that this one right here on the top is a difference of two squares, and it's going to factor pretty nicely. So you could do it that way. The second way, if you don't see that this is a difference of two squares, you could just work this out. Okay? I'll show you both ways. So if I see it's a difference of two squares, then I would have x plus h plus x and x plus h minus x all over h. If I don't see it, the other way would be again to work this out. So I'm working out x plus h times x plus h, and I would get x squared plus 2xh plus h squared minus x squared, all over h still. All right, let's go back to the difference of squares way. Combine like terms in here. I'll have 2x plus h, and then, oh, the x's are gone. I just have an h. Isn't that nice? I told you those denominators would cancel out, and I'm left with 2x plus h is my final answer. Let's see if I get the same thing over here. Oh yeah, those x squareds cancel. And what can I do up on top? I could factor out an h. And look at that. Denominators cancel. I get the same answer. So I don't care which way you do it, but if you recognize difference of two squares, that's pretty quick. If you don't recognize it, you just have to do a little foiling and you should get the same answer. All right, I know I'm going fast. Pause the video if you need to. Go back and try it, redo it, check stuff. That's why this is on a video. That's why I'm going fast. You can stop it, rewind it anytime you need to. Letter B is going to be a reciprocal function, 2 over x. And again, we're going to do the same thing, g of x plus h minus g of x all over h. This is going to give us a complex fraction, so good practice reviewing how to solve a complex fraction. I'm going to take this whole thing, x plus h, and plug it in for x. So I'll have 2 over x plus h, that's this first part, minus g of x, oh, that's just 2 over x, but it's all over h. To be really careful because this h down here is technically h over 1, right? So I want you to write it as a fraction just so you don't miss that little fact because it is very important. Now this is where you get to pick method 1 or method 2, and in a minute you're going to go in your practice packets to page 8, which is just a review of that kit from method 1 and method 2 with complex fractions. Pick the method you like the best, right? So pick your method that you like the best. I'm a big fan of method 2. So I'm going to multiply everything by the OCD, which in this case is just x plus h times x. Both of those two. Down here it's just a 1. And I have to multiply everything, every single term, by that common denominator. Okay. And stuff should cancel. So gone, 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 gone. Down here nothing cancels and that's okay. Up at the top now I just have 2x left minus 2 times x plus h. On the bottom I have an h, I have x plus h, and I have another x. And I'm going to leave them all like that. I'm not going to FOIL it out down there. But up here I should definitely distribute, because what happens, keep the same denominator, is the 2x's are gone, and I just have a negative 2h on top. And then what happened? Oh, it canceled, right? I always told you something from that denominator is going to cancel. Not necessarily the whole thing, because this was a fraction to begin with, so we're going to get a fraction answer. But at least part of it did simplify and cancel. And so this would be my final answer. And you can leave that denominator like that. You don't have to work it out. If you use method 1, get a common denominator here and then flip and multiply, you should get the exact same thing. Okay? All right, that is it, I think, because page 11, I'm going to let you do it on your own. You don't need a video for it. So if you want to do page 11, just go ahead and copy it down because it's more of a physics example. It's sort of an optional. So I'll put optional. If you do want a good extra physics example, especially for those of you in physics right now, it might not be a bad idea. Go ahead and try this example. And it's just the answer key is online. But I'll leave that one as optional. That's it.